All right, I'm Kevin Libwit, joined by Andrew Page. We're from Fusion, and this is the Bioinformatics Lab podcast. And this and maybe a couple few episodes we're going to be dedicating to exploring COG UK, or really introducing maybe even COG UK to a couple of folks. This being one of the premier consortiums of SARS-CoV-2 sequencing that really became the model of a lot of international groups that were addressing this exact problem in terms of setting up sequencing analysis and reporting during the COVID-19 pandemic. Andrew, you obviously played a huge role in that. So maybe if you
Yeah.
don't mind giving a first an introduction and overview of what is COG UK, what was intent, how it was started, and we can start there.
Yeah, so it was the COVID-19 Genomics UK Consortium. It sounds very grand, actually, but it was a lot of people who knew each other from the UK scene and genomics scene because it's a small country, small world. Everyone knows everyone else. A lot of people from bacteria and infectious diseases in humans. You go to some conferences and stuff. So we did all know each other. And so come about March 2020. There were calls going around to get some sequencing up and running. I was in a Quadram Institute at that point, and we were thinking, okay, let's get the primers in. Arctic had released their primer set for SARS-CoV-2. Let's get the primers in, and we can be ready to go. And then, we're doing back of an envelope calculations that we could do so much testing and so much sequencing. We don't, we'll just do anyway. And I got a few test samples in from one of the hospitals in London through Justin O'Grady, who then got COVID because of that. Just being down in London, going on tubes and like the subway. Um, and so GOG UK kind of got kicked off. I shared an office with a part-timer called Tom Connor. He was never in the office, but he still had a desk beside me. And so he got in touch with us and was like, hey, would you guys like to be, in a little do a bit of genome sequencing? We're like, yeah, sure. We didn't know was there any money in it or whatever. That wasn't the point. It was just, everyone was kind of rallying around to help out. I was on jury duty at the time. And then the cases all collapsed because, everything was just going to hell. And I got exempted then because of the type of work that I do, along with most of the jury because everyone had an excuse. And so I went back to work immediately. And so, yeah, we started planning for sequencing. And we just got a press release on a Sunday evening, a day or two later saying, oh, we got like $20 million or 20 million pounds for sequencing. Is like grand, we'll kick things off. And so the general idea of it was decentralized sequencing to just use our local contacts to get as much sequence as possible. So, it was maybe 13, 15 different centers around the UK, universities, public health research institutes, that kind of stuff, public health bodies. And we just linked in with the doctors and the local hospital departments that we knew. And we're setting everything up to get samples in to sequence. And actually, we got through ethics and paperwork in super quick time because everyone, was really, really motivated to push things through as fast as possible. And so
Around
we
what month
started,
was this? 2020. You say it's still early
this
2020.
was late March 2020. And so I think the first sequencing, like live sequencing we did was the 8th of April 2020. So I took about a week to get live samples in. Previously, we had, we were getting samples we were retrospectively sequencing. So that's when he kicked things off. And then we didn't stop sequencing for 2 years. We did sequencing every single week, week in, week out, no matter what time of year. And it was the same with the rest of the consortia. So my role was initially as the kind of PI for that little region, along with a guy called Justin O'Grady. We kind of split down the middle. He was doing the wet lab stuff, and I was doing the bioinformatics. Then later he went to Nanopore, so then I was just leading the whole kind of production side and getting stuff out the door, which is kind of hard. But it helped that funding wasn't an issue. It was just do what you need to do. We had a lot of
Yeah.
support from all the higher ups in our organizations. Just don't worry about money, we'll sort that out. You guys just go sequence, and all that data was being fed into one big database in MRC Climb, which is like a cloud computing system for academics. and it was being put together. So you can't see my hand gestures, Jesus. But it was being put together in Climb, and then people were writing, another team were writing reports on top of that. And I was
Yeah.
going up to SAGE, the Scientific Advisory Group for Emergencies in the UK. And so that was advising government directly. And so they were getting the scientific evidence for government to make informed decisions using data. And around that time, the UK was responsible for more than half of all SARS-CoV-2 data in the world. And it's because at that time the US wasn't really sequencing much because for political reasons, which we won't go into. But when there's a change of
A
leadership,
different
things improve.
podcast.
Yeah.
Wait, I'm curious because in that retelling of the narrative, of the origin stories, there's kind of an important section there that I'm most interested in that you kind of glossed over, where it went from an informal group of scientists who were doing the things they would have been doing anyways, in terms of sequencing emerging infectious diseases and collaborating. But then there was something you mentioned, and then there was 20 million pounds to fund it. So how it went from
Yeah.
sort of an informal group of a ragtag group of scientists doing what they do into a government funded consortium that was now dedicated resources to this. So what did that conversation look like? And how much of that success was of COG UK was dependent on all this pre-existing infrastructure of high quality sequencers, bioinformatics knowledge, and the sort of communication tracks already put in play across the different states.
Yeah, so Sharon Peacock led this. So Professor Sharon Peacock from the University of Cambridge, she led the consortium and did the paperwork to get money. And the bar was very, very low at that point. It was anyone who can help in any way possible. And money was being shoveled out the door. It was good that the resources were made available as quickly as possible. And so she led consortium, and a few other people were the official PIs on that. And the secretariat was in at University of Cambridge. And so she brought everyone together. But, it's a small world. And so I previously worked with her in the Sanger Institute because she had a joint position there. And I've worked with some of the other PIs, we've been friends with them, or met them at conferences. So it was very much a pre-made community that just was all set aside their rivalries that are very common in academia and just kind of mucked in and started sequencing. And from the very outset, it was, we want to sequence, get an idea of surveillance, and then make the data publicly available as quick as possible. And so it was always very much get the data into the public domain. We don't know what we can do with it. And there were downsides as well, because if you're doing half the world's sequencing, then of course, anytime someone finds something, they'll go, oh, well, that's a UK problem, we can trace it back to there, but it's simply because of volume. And we were sequencing crazy amounts, I think at one point in the summer of 2020, my group had sequenced like 40% of all positive cases in the area. So it's very high density. Sorry, people hospitalized. So it's very high density at that time. And at the time, methods were still being refined and developed, and costs were coming down massively. Like initially, I think it was about £75 to sequence one sample, and then that cost kept getting hammered, as people refined the methods and tweaking the reactions.
What was that process like? Because you talked about academia now, or rather in previous episodes, we talked about the difference of academia and public health, where in academia, you're always kind of bleeding the edge, always trying to tweak and optimize different protocols. Whereas in public health, you want standardization across all these teams. So whenever you have academic entities that are now reorienting themselves to be sort of a public armed service, what did that look like? How was it quick buy-in from everybody? Of okay, it looks like Andrew got the bioinformatics tool. Everyone use that. He's got, Justin's got the wet lab approach. Everyone use that. Or what was that communication like, that transition for academics to play public health scientists?
It was complete opposite to that. It was the benefit of having academics is the rapid innovation, because there was no set way to do things. So what we did was as much innovation as possible, in different ways of tackling the same problem. So, like people using Nanopore and Illumina, there's no fixed way of doing it. People are doing different protocols, different variants of protocols. Sure, it introduces batch effects and stuff like that. But overall, it meant that we could get there quicker. We could find solutions quicker. And when one protocol wasn't necessarily working, there's others to fall back on. And so that helped drive a lot of the very rapid expansion of this stuff. It was difficult for academics, I think, because having to switch from from an academic research retrospective look to a production, is quite difficult. And then, over time there was, pressure to reduce the turnaround times, I think one time we got from sample to result in like under a day, like I think it's like 12 hours. When you really need to push things out, you could, but it was very much about that innovation. And then, we guys in the lab who would be tweaking the reactions as they went along and, finding that actually they don't need to add as much, at this point they can, kind of trim it down and then save money and save time, cut out steps, because, steps aren't necessarily always useful. Like, you'd have things written in protocols like you have to keep the DNA on ice, and it's like, well, you don't actually. That's someone's written it in somewhere and it's been mantra, but actually it's stable for weeks. Like just sitting on the bench.
Yeah.
The cDNA and things like that. So it was about changing and finding the best for each two things, and we found things accidentally working. Like one time we did 4 reverse reads, but the reverse fails. But then the 4 data was actually very usable, and it's like, okay, well now we know we need half the data, and all these things accidentally happening to help us refine stuff.
But what an incredible story and like narrative of how powerful collaboration can be, especially in sometimes where it can be quite competitive in academia, and then also that bridge between academia and public health, even making sure that communication was strong, and how much sequencing data, how really real time it got to. You're talking about 12-hour turnaround time. That's always been sort of the goal, is real time genomic analysis. And so I think from CogUK, and as I said in the beginning, it set precedent of like what a collaborative consortium can do and look like for other international entities. Like in the US, Sphere is, a lot of us on the US side of things, we're looking at what the heck is CogUK doing? How are they setting up these collaboration communication? Like, we should be doing this as well. And then obviously Canada, something similar with Cancogen and others around the world. So clear impact of during the pandemic. Can you speak to how, at least in the UK, has it forever changed those collaborative walls, or like now that we're kind of at least past the craziest of those COVID-19 waves, what role does CogUK play right now, or those relationships, and how has it changed kind of the spirit of communication?
I guess it proved that the utility of genomics, because the amount of information and data, and for the first time, the public were thinking about genomics and surveillance and things like that. People who probably never heard of before that, but politicians and everyone, were now focused on that, and they understood it, and that mindset change has helped a lot for everything. So now there's less of a barrier to translate the academic stuff into the clinical lab and into public health. So yeah, we've broken down barriers, and we probably advanced 10 years in terms of just that governance and thinking. Which is fantastic. And then academically, well, people know each other now. Those friendships and links have been made, and they won't be, they'll go on forever, and as long as people are alive. So that's a very good thing. And yeah, so it did advance that translation piece, because for years, like I've been hearing, oh yeah, we're translating it. We hope to get into clinic, in 10 years. And this, just really sped it up there. We're actually doing stuff with genomics, with the data, and making decisions and changing policy as we go along.
I think that's a good way to describe it. I've always looked at it similarly, where our conferences, our corners of the technical universe, we all kind of saw the impact and value of sequencing and how it could inform public health decisions. during the COVID-19 pandemic, the value became undeniable. It's like, okay, we need to understand what kind of lineages are spreading to inform the decisions that public health officials need to make. And so it became a required technology to be able to look at this kind of resolution. And as you said too, now that there's an obvious, it's in the public psyche of genomic data, public health, and infectious diseases. So now, even during the pandemic, when a lot of the investment came into play, the conversation was always, how do we make this long-term and organism agnostic? How do we take the tools and infrastructure we're building for SARS-CoV-2 and ensure that we can also utilize those resources for TB, AMR, enteric pathogens, and all the like. So, but yeah, so COG UK played such a pivotal role in I think changing our understanding of how academic, public health, and government institutions can work together. Amazing thing that I think we're going to be talking about for a couple episodes, even your specific role, some of the interesting papers that came out of it and the like. But I think this was a good kind of original primer on COG UK. Anything else you want to finish on to wrap up
No, well,
this
it was
episode here?
a very busy few years, during the Cog UK thing. I learned a lot, and yeah, I hope the lessons that have been learned will continue to be in the public mind.
And I think that's a spirit shared by most. So, all right, yeah, we'll end it here and continue speaking about this in future ones.